Uh-oh. Now we're talking about acceleration. So we're going to use two formulas. One is F equals ma, and one is E is F over Q, right? We're also going to look up the charge on a proton, right? The charge on a proton is the elementary charge, so it's positive 1.602 times 10 to the minus 19th coulombs. Just keep that in mind, right? Electrons would be negative that, protons are positive that, okay? And then the mass of a proton is 1.673 times 10 to the minus 27th kilograms, okay? Somebody asked, I think Ethan Dibble asked me, he said, well, it says rest mass. Does the mass change when it moves? And we won't get into this because we're not doing relativity. But yeah, sure, it does. You know, in fact, I believe the protons at CERN increase their mass by a factor of like 1,000,000 or something like that. I could be off by a factor of 1,000 either way, but yeah. So the mass changes. That's the whole point. And the reason it changes is that E equals mc squared, right? So the change in mass is the kinetic energy that it gains over c squared, which c squared is a big number. So it's not a huge change in mass that we notice at normal speeds, but it does happen. So, all right, so let's take a look at this guy. Proton accelerates north. What is the magnitude and direction of the electric field? So the electric field is going to be force over Q. Force is ma. So now we can just plug in numbers, right? So 1.673 times 10 to the minus 27. Acceleration is 9.58, right? The charge is 1.602. Now we're set. Let's see, divided by 1.602. And I get, whoa, I must have contrived those numbers. I get 10.00458. We have 3 sig figs, so we'd say that's newtons per coulomb, right? Now, this acceleration was north. There are no minus signs here, right? This is a positive, mass is always positive. This is a positive charge. So that would also be north, okay? So if the proton is accelerating north, that means that there must be what, positive charge to its south, or negative charge to its north, or both, right? There it is, right? Just have to be careful. It's a positive charge, whichever direction it's accelerating or experiencing the force, that's the direction of the electric field. If it had been a negative charge, right, then you got to be clever about it, right? Because the electric field would be the other way. Negative charges accelerate. A negative charge in this field would accelerate south. Okay.